Hey all, I just thought I'd do a quick overview of trigonometry. I've had a few questions about sort of the more basic things. There's another video about using the unit circle and the ratios to find exact values. But I just want to go back to the sort of basic things of the trigonometric ratios. So, we use the Soh Cah Toa little acrostic thing in order to remember these ratios. What they do, the sine, cosine and tangent functions, is they give us a relationship between an angle of a triangle, so we can call this angle theta, or we can just call it an unknown value x. They give us a relationship between the angle and the sides of a right-angled triangle. And the idea is that if we enlarge or shrink this triangle in other ways, even though the sides can change, if the angle remains the same, then the ratios will be the same. So if you imagine, if this angle, for instance, is half as long as this side here, if we enlarge it, the ratio, it still stays half the size. Okay, so for these labels, we have opposite, hypotenuse, and adjacent. And all of those terms are with reference to the angle that we're using, or the angle that we're interested in. So the opposite, the side over here, this side doesn't intersect with the angle anywhere. Notice how this side here is the hypotenuse, and this remaining side, both of these meet where this angle is formed. The opposite doesn't share an angle there. The adjacent side, which is over here, so it sits with the angle, it meets at the angle there. And then the hypotenuse is over here. And it's opposite the right angled triangle. So, I mean, it's also adjacent to the angle, but the hypotenuse is always just the side, it's the longest side of a triangle, and it's always opposite the right angle. So these are our basic ideas. And then so sine x tells us that, so it's the opposite over hypotenuse. And what this means is that if we take this angle here, the sine of that angle gives us this ratio here. So it transforms that angle here. So maybe the angle is 40 degrees, maybe it's 20 degrees. It says, okay, if the angle there is 20 degrees, then this ratio is equal to sine of that angle. So it's basically a transformation type function. Then we have cosine of x is adjacent over hypotenuse, and then tangent is the opposite over adjacent. And we can start off imagining sort of some ideas. Firstly, since sine is the opposite over hypotenuse, if this triangle gets smaller and smaller and smaller, so imagine like a triangle that's infinitely, shrinks, this angle gets smaller and smaller, and so does the opposite side. So we know, for instance, that sine of 0 degrees, so as that approaches 0, the ratio would be 0 on whatever the hypotenuse is, and so the ratio of that is just 0. On the other hand, for cosine, as that triangle gets smaller and smaller, so cosine of, say, 0 degrees, that goes down to here. It's the adjacent over hypotenuse. As this becomes thinner and thinner and thinner, the side here, as a ratio with the hypotenuse, they almost end up being the same. So it ends up being close to 1. We don't worry about these values too much, but it's an alright idea to think of it. And then so, as an extra activity, imagine what would happen if we had the other type of triangle. So as this triangle and this angle here, so right angle triangle, and as this angle here approaches, say 90 degrees, what happens to these ratios? So it's worth thinking about that. Okay, now in the context of the questions that you're asked to do, for instance, in the practicals, one of the questions was about using the standard triangles. So these are the two standard triangles that we have. The first one is an an isosceles right-angled triangle. So the idea is that this side is the same length as this side, and so therefore these two angles are the same. since we've got a 90-degree angle, they must be 45 and 45, or in radians, they're going to be pi on 4 and pi on 4. And so the ratios here, since we're only interested in the ratios, we set these side lengths as 1 using Pythagoras' theorem. We need to refresh on Pythagoras' theorem. It's that a squared plus b squared equals c squared. So from particular triangle here, we'd have a and b, or we can swap those as well, but c is the hypotenuse. C. And so there, it's a very famous theorem as well, been known for a few thousand years. So we can use that to get our trigonometric ratios here. So this just tells us that, even though we could have right-angled triangles like this that are bigger, if we have 45 and 45, the ratios still have to be the same. The triangles themselves will have different lengths, but the ratios, so for instance, tangent is going to be opposite over adjacent. With this kind of triangle, those are always going to be the same length. So that's one of our standard triangles. The other one that we have is this guy here. This one starts with a equilateral triangle, so it starts with all angles equal. Since all angles are equal, then we would have 60 degrees at each of them. We then cut it in half, and so we get, if we start with side lengths of 2, then we get this, we just think about like this side of the triangle, and so we've got a 2 there is the length of the hypotenuse. The bottom, since we cut that side in half, is 1. And then using Pythagoras' theorem as well, we get this as root 3. So it's one of our other triangles. And we see here again, so whenever we have a triangle where this is 60 and this is 30, or pi on 3 and pi on 6 in radians, then the ratio, for instance, of the opposite over the hypotenuse from the point of view of this angle, this 60-degree angle, is always going to be root 3 on 2. So opposite over hypotenuse. Okay. So how do we use this to solve questions like that's given in the study guide? So I'll just do one, and then we'll think about it. So if we are told, for instance, that this is 60 degrees, and this is x, and say this is 4, something like this. I think there's a question of that type of nature in the study guide. Let's get that ready. Okay, so what these basically allow us to do, have a look at the ratios again. It has 3 values that it gives us a relationship between. So the idea is, if we know 2 of these, any 2 of these, we can automatically work out the third one just by solving. So if we want to find x here, we look at the bits of information that we have, and we fit in x to a triplet, essentially, of information, and then we can find it the remaining way here. So we know this angle, okay, so that's one bit of information. We've got an angle. From the perspective of this angle, we know the opposite, so we know what the opposite is. And then the quantity that we're interested in is this value here. It's the hypotenuse. So we have 3 bits of information, an angle, an opposite, and a hypotenuse that's unknown. We can do it like that. So, going across here, we see that the trigonometric ratio that relates these 3 things is exactly the sine. And so that's the bit of information that we're going to be able to use to be able to solve this question. So, let me remove here. So I set up my equation, and so I say sine of my angle. Remember, in these trigonometric ratios, this value here, even though it's an x, or it can be a theta, it's still referring to an angle. So here we have sine of our angle, 60 degrees, must be equal to our opposite, which is 4, over our hypotenuse, which is unknown. So we get this information here. Now, in those questions in the practical, it says use our standard triangles. And so the idea is that we actually know sine of 60 already, and we can determine it without a calculator. Because we saw what sine of 60 was in this triangle here. So, having a look at this triangle, we see that the ratio for sine of 60 degrees is opposite root 3 on 2, opposite over hypotenuse. So sine of 60 we can evaluate, it's just root 3 on 2. And we know, or what we're interested in is it being what is x equal to here. And so now we've just got this equation, it's just all numbers and just an unknown x. And so solving this around, remember we don't like x on the bottom, so we can multiply by x. So we get x outside of root 3 on 2 equals 4. So that was just multiplying both sides by x. And then, in order to get rid of this root 3 on 2, we can multiply by the reciprocal. So that's going to be multiplying by 2 on root 3. Reciprocal just means the fraction upside down, because remember if you have a reciprocal, so root 3 on 2 times 2 on root 3, these terms just cancel out, it just equals 1. So, doing that I get x, you can still see there, x being equal to 4 times 2 all over root 3 equals 8 on root 3. Okay, so just in case, yeah, I think it's still in the picture, but we'll do that. Okay, so that's how we do that kind of thing. Now, as a last sort of thing to leave you with, so remembering what all of these things do, get rid of this. So remember it's Soh Cah Toa. Okay, so if we instead had, say, 45 degrees here, we have x here, and we have, say, 1 here. Let's not do 1. 1 is too easy. Let's do 7 here. Okay, so let's say we have a triangle like this. Now, going back to what we just did with the previous example, so remember each of these relates 3 bits of information. The question is, which 3 bits of information do we have? Okay, so think about it for a second. What are the 3 bits of information that we have? Okay, hopefully you've thought about it. So, the 3 bits of information, remember we've got an angle here, and it's known. We've got an opposite, but it's unknown. And lastly, this side is classified as the adjacent. It's the thing that's not, and it's known. So then we just have to go to, okay, what information do I know? And I've got tangent here gives me the relationship between an angle, an opposite, and an adjacent. So I'd start this with the tangent of 45 degrees equals my opposite, which is unknown, x in this case, over 7. And then evaluating this, I can see that I know tangent from 1, tangent from this triangle of 45 degrees, opposite over adjacent, it's just 1 on 1, tangent of 45 is itself 1. So I would just get 1 equals x on 7, therefore from this I can get that x equals 7. Okay, so I hope that helps a little bit. Good luck with all your study, talk to you soon.